Hi Engineering Janta, I am Vaibhav Shukla, and today we'll be understanding the code part or the code implementation part of the method 2 of stack implementation. Fine. This is another video in the free DSA series that we are building for you so that you thrive high in your career. So let's straight away dive in deep to the coding portion. Fine. So what I'm doing is, first of all, I'll create a structure of that node. Fine, that I explained to you in the last video. If you have watched the last video, you will easily understand. So for that node, if you correctly remember, node looked like this, and it had two parts. One was value, the another one was pointer or the address to the next node. So I have a pointer node star next, and I have an integer value that it would store. Fine, so this is the structure of a node. Now I declare a class stack, and it has a head pointer, it has size, and I initialize head with null, which basically means head points to null. Fine. Size is right now 0. I'll keep on updating the size as I add the elements into it. As simple as that. Fine. So what will happen, I'll go ahead, I'll show you the implementation of push. Why am I saying that I'll keep on increasing the size as soon as I add elements? That is the benefit of a linked list generally, that you can adjust size dynamically here, right? There we had to declare size, if you correctly remember. There we had to declare size, and then stack overflow could exist. Here also it can exist. We can have a condition, we can have a predefined size, and we can consider that this is the maximum size a stack can have, and then overflow would happen. But right now I'm not imposing any such condition. Right now the size is 0, fine, and we'll keep on dynamically increasing. More the number of elements, more the size. As simple as that. Fine. So what will happen, I declare a function as push. Fine. So if I declare something as push, what will happen, I take an integer value in this push function, then I create a new node. First of all, consider this is a stack. Fine, or rather let's think it in the terms through which linked list can be easily understood. So consider this is a stack. Fine, your stack is now horizontally aligned. Fine, and now in this case I create a new node. First of all, right now it is empty. Fine, so I create a new node. What will happen, the temporary node that I have created now has value of x. Fine, so just consider this is the temporary node. Fine, and in this there is the value of x that I store. Say I pushed 15, so 15 it can store. Now there was a head pointer there was a head pointer here which was pointing to null. Why so? Because this stack had nothing inside it. Fine, so it is empty, so it was pointing to null. Now what I'll say is, I'll put this particular place. Fine, I'll replace what was being pointed out by head. Fine, so the next pointer, this is the next portion, this is the pointer, you can say this is next. So this next pointer will now contain the value which points to head. Fine, is it true that I just spoke? No, it's not. Basically it says it will have the value that this head points to, which basically means null. Fine, so head points to null right now. So now the value that head contains for the pointing is null. This null would be stored here. Fine, so here I can say that this particular portion, now this next points to null. Fine, this next points to null, and the head points to this particular temporary node. This node is temporary node. Now to this area, this head points. Fine. So if I correctly arrange this arrangement, what will happen? Pointing to null means pointing to nothing. Fine. So I can literally store null here. What I'll do is, I'll take this element. Fine. I'll put this node here, and this is 15, and this is null, and head points here. Fine. So this is the first element that I added. Now head points to the 15. This is the topmost element right now in the stack. You might be confused after what I just did. You will get better clarity when I add the second element, because now you will have something for reference here. Fine. Now head is pointing to this particular node, which is the first element right now, or the only element in the stack. Now what will happen? I try and push again. Say I first did push 15, right? Now I'm doing push 17. What will happen now? 17 will come here. Fine. 17 comes here, right? In this case, again I create a temporary node. Fine. So again a temporary node is created. I store the value portion 17 in the value portion of this temporary node, and the pointer, then this portion which stores the pointer to the next node, stores the pointer to which head was pointing. Basic बात ये है, head जहाँ point कर रहा था वो pointer यहाँ आ जाएगा, ठीक है? Because head में जो value होगी, जिस node का address head में होगा जहाँ वो point कर रहा है, वो मैं उठा के यहाँ डाल दूँगा, so that ये point कर पाए, ठीक है? तो what I did was, I did this. Fine. तो मैंने इसकी वैल्यू यहाँ डाल दी है. पहले हेड पॉइंट कर रहा था और अब हेड को मैंने कहा यहाँ पॉइंट करना शुरू कर दो. फाइन. इस टेम्प पे. फाइन. और एक ये मैं आउटपुट फॉर माई सेल्फ प्रोड्यूस करा रहा हूँ. सी आउट एलिमेंट एक्स पुश्ड इनटू द स्टैक. लास्ट टाइम भी एक चीज जो मैंने नहीं बताई वो थी कि साइज इंक्रीमेंट होता रहेगा. हर बार जैसे ही ये एग्जीक्यूट होगा फंक्शन तो साइज की वैल्यू बढ़ जाएगी. तो जब एक एलिमेंट ऐड हो गया होगा इसके बाद तो साइज की वैल्यू यहाँ पर 0 से 1 हो गई होगी. साइज प्लस प्लस हुआ और वो बना 1. अब जब ये पुश होगा एग्जीक्यूट तब देखेंगे साइज की वैल्यू क्या आ जाती है. ठीक है. तो अब ये ऑलमोस्ट एग्जीक्यूट हो चुका है तो यहाँ पे आ जाएगा एलिमेंट 17 पुश्ड इनटू द स्टैक. बट अब ये स्टैक कैसी दिखने लगेगी? इफ आई करेक्टली प्रेजेंट इट नाउ तो कैसी दिखने लगेगी? कुछ ऐसी दिखने लगेगी ये स्टैक, है ना. और हेड यहाँ पॉइंट कर रहा होगा. राइट. सो नाउ इट हैज 2 एलिमेंट्स. फाइन. Topmost element is 17. Now size plus plus happens and due to this size becomes 2. Is the size of stack 2 right now? Yes, it has 2 elements. So in this case, one can say that stack is always full, isn't it? So how to add size into it is your homework. How to add size in such a way that size is fixed initially. Can it happen here or not? First of all, think that. If that can, how you can do that? Go ahead, tell me in comment sections. Fine. In comment section, you go ahead, put it out in the comments. Now, we'll implement pop function. Fine. In this case, how does the pop get implemented? Very simple. What I'll do is, I'll define a different pointer to this particular node. Fine. I'll change some matrix. Basically, I'll change the head and I'll start pointing to this element and I'll delete this particular node. I'll tell you what I'm trying to do. Don't worry. So when I proceed, first of all, understand that there was a point when we had no element in our stack and head was actually equal to null. So had that been the case right now, we would have said stack is empty. But right now this is not true. Head is not null. So this if block will not execute. Had it executed, we would have given stack is empty, and then we would have returned, this function would have executed enough. Fine. So right now this block will not execute. Fine. What I'll do is, we have our stack something like this right now. We have a node here 15 and null, right? And then we have another element whose next pointer points to this place. Fine. And we have a head. Fine. I guess I can write better next than this, so let's make a bigger node. This is 17 and this is next. Fine. So now in this case what I'll do, I'll create a pointer. Fine. And I'll copy paste, I'll just assign the value of this head to this temp. So basically I have a temp pointer here which is pointing to this particular node. Fine. Now once it starts doing this, the next of it, basically the next of temp is this, right? The next of temporary, the next pointer of temp is what I'm copying to head. Basically I'm copying this next. Temp is pointing to a next, which is next. Fine. This is a pointer pointing here. Fine. So to this I'll say this value I'll store to head, which basically means I want head to get the value of this, and I'll want head to point out here. Fine. I'll want head to point out here where next is pointing. So it would look good if I create it like this. Fine. Now in this case I say that this next should now be pointing to null, or there should be null value here. Fine. So now I do null value here. Very simple. Fine. And now if you practically see, this particular node has nothing to do with our stack now. Why am I saying so? For computer, now this stack is looking something like this. See, it is having a node 15 which is further null, and head is pointing to 15. So there is just one element for the computer in the stack, or for us in the stack, and this particular node where temp was pointing is of no use to us. It exists or not, it's of no use to us. So we just delete it and we say element popped. Fine. The element is popped. What you can do from your end is, you add a cout command before this delete temp happens. You add a cout command yourself and try and figure out, can you print the value of this? Fine. Can you print this value? Can you print this 17 on the screen before you delete this temp? Fine. Before you delete this pointer, can you print out this value? Number one. Post that, you will print out this element popped, and then size would be decremented, which basically means now size is again 1. Fine. If I go again, I say once I did pop, this happened. I again do pop, this will also go. Fine. This will also go. I'll show you how. See, let's try and implement it again. Fine. We'll try and implement it again, and if that happens, let's see what happens then. Fine. So I do that pop again. If I do the pop again temporary is a pointer that is established. For this next portion I have null, so basically head will start pointing to null. I'll copy the value here, no, because I copied the value of head to temp. Temp starts pointing to 15. I go to the second step. Head is equal to temp pointing towards next, or the next portion of the temporary pointer, which is this null. What I'll do is, I'll copy this value, or I'll make head pointing towards null. So basically head is now pointing to null, right? When head is pointing to null, this stack is empty. It is clear. Now when this stack is empty, what I'll do, I'll update the next portion with null, which is already there, and then I'll delete this. Fine, so I delete this. So nothing happens. All I can say is now null exists here, nothing exists here. Fine, the stack is empty. Now if I do, and size gets decremented to 0. Fine. Now if I do pop again, if I do that again, what will happen? This condition will get fulfilled. So this time the output you will get is stack is empty. You will get this output. Fine, you will get this printed. So that is how pop is implemented, and this is the basic linked list implementation. Now there was peek function, isEmpty function, isFull function. Go ahead, those are your homework. Do that and put your solutions in comments. I'll check them and reply on them. Fine. Remember one thing, ऐसा कोई जादू की छड़ी नहीं बनी है दुनिया में जो कोडिंग सिखा देगी. So I have put out enough videos where I have literally walked you through step by step through every solution, through every code implementation. Now it's time you start writing a few things on your own. Fine. Try and write. I'm not entirely putting you that you write the linked list implementation from the scratch, but you write a few functions. Fine. And if you go with this pace, one day you'll be writing solutions on your own. That is how you try and learn to write solutions on your own. Fine. So go ahead, implement peek, isEmpty, isFull function, top function. Make a top function, just like peek function, okay, which returns top element. Fine. Do it twice. It'll help you. Fine. So go ahead, follow us on these social media handles so that you never miss any hiring update, and top 3 comments get Prep Insta Prime subscription for free. So do not miss out on this free subscription. This can be a gold mine. If you comment below this video, and you will be commenting because you now have homework, fine. So give me your homework solutions, I'll check them out. And if your homework solution is too good, you can stand a chance to win the free 3 months Prime subscription. If you have watched the earlier video, I have clearly done a giveaway as well. So go ahead, you might be lucky, and keep doing good for others. Good will come back to you. Fine, that's all for today.